Hi everyone. Welcome to our derivative discussion using the chain rule. So as an introduction, let's differentiate between power rule and chain rule. Now given the same equation or the same function, the power rule suggests that if we have this mx to the n, then the rule says you multiply n to m. So it's going to look something like nm, okay, times the base x raised to that n minus 1. Okay. While the chain rule is actually a generalized power rule. So this is a power rule with one extra step. So what we do is exactly the same as the power rule for our initial step, which is nm, that's n times m, multiplied by that same base x raised to n minus 1. But with one additional extra step, which is the derivative of this x, which is 1. So you have to multiply it by the derivative of that base x, okay? Now, the reason why we're only using power rule, whenever we have a plain x as our base, because the derivative of that x is just 1 anyway. So even if you multiply it by 1, you're still going to get that same nm x to the n minus 1, okay? But this is the generalized power rule. So we're going to call it the chain rule, okay? It's like a chain. All right, so let's get to the point. Let's look at example number 1, okay? So if we have this function 6x squared raised to the third power, so you can see that the base is no longer, okay, plain x. So it's no longer plain x, so we have to use the chain rule, okay? So use chain rule. It's like a generalized power rule. So our y prime is going to be what? So the coefficient of this quantity is 1. So you multiply 3 times 1, which is 3. Now copy that same base, okay? 6x squared, and then raise it to the 3 minus 1, which is 2. Now because the base is no longer plain x, you have to multiply this by the derivative of this 6x squared. And the derivative is 12x to the first power. All right, that's it. You just have to simplify. Simplify means 3 times, now the 6x squared is going to be 36 x to the fourth times 12x. Okay. So that's going to give you now 36 times 12. Okay, so 36 times 12 times 3 is going to be 1296 x to the, okay, 4 plus 1 to the fifth. Right? That's your number 1. Suppose we have a 3x minus 5 squared, okay? So what is the derivative of 3x minus 5 squared? Okay, so it's like you can rewrite this as y equals 3x minus 5 squared, and what is y prime, okay? So the derivative now, one way to do it is, okay, if you saw my other video, I use the power rule exclusively for that particular video. And I have a similar example where we have this binomial squared. And to use a power rule for this, okay, so if we're going to strictly use the power rule, what we can do is to rename this by multiplying 3x minus 5 by itself, or expand it, FOIL it completely so that you get what? 9x squared minus 30x plus 25. Then after we use this algebra, then you can go ahead and do your power rule, okay, individually for each term here. So we have 18x minus 30, derivative constant is 0. So you see, you can use the power rule, but you have to do some kind of renaming initially. Now you don't have to do that if you use the chain rule. If you understand that if the base is not plain x, then you can use the chain rule. Okay, so first, looks like a power rule, 2 times 1, copy that same base, okay, copy that same base, and then raise to that 2 minus 1, which is a 1, but you have to multiply it by the derivative of this base times 3, okay? So our y prime is going to be what? 3 times 2 is 6, and then multiplied by the 3x minus 5. So your y prime is 18x minus 30. As you can see, it's the same as the y prime we got using the power rule, okay? Let's see number 3. Okay, let's say you have a little bit more complicated binomial, 3x to the fourth minus 4x squared, and then raise it to the second power. So you go ahead and find the derivative, okay? So the derivative of this using chain rule, again, we have the coefficient of this, okay, coefficient outside this quantity, there's a 1. So you multiply 2 and 1, which is 2. Now copy this base, okay? So using the power rule, you have to copy that same base, 3x to the fourth minus 4x squared, and then raise it to 1, okay? Because 2 minus 1 is 1. Again, the base is no longer plain x. So this is not plain x. That's why we have to use the chain rule, okay? So multiply this by what? By the derivative of this thing here, which is what? 12x minus 8x, okay? And you can just rearrange it, 12x minus 8x, okay, times 3x to the fourth minus 4x squared, or you can go ahead and expand it, FOIL it out, okay, but this will be good. Right, let's look at number 4. Okay, I'm gonna raise this binomial now to the 5th power, okay. Also in my other video about derivative using power rule, I showed how to expand this using a very easy technique, okay? But we don't have to do that. You don't have to expand it because now we know the chain rule. So the derivative is simply what? Okay, so multiply the outside number 5 times that 1, which is 5, and then copy this base here, 2x plus 4, now raised to the 4th, okay? And then multiply this by the derivative of this thing here, which is 2. All right, and that's it. It's 10. Okay, multiply 5 and 2, which is 10, and then 2x plus 4 raised to the 4th power. All right, let's go ahead and look at number 5. Now, I have a little bit longer polynomial here, function, okay, and then raise it to the 3rd, okay? So now you can appreciate the chain rule. Without the chain rule, you have to multiply this polynomial by itself 3 times and then use the power rule, okay? But you don't have to do that anymore because the chain rule allow us to just do it very quick, okay? So again, the coefficient here is 1. So what we do using power rule is multiply this 3 and 1. So it's 3. And then 6x cubed minus 4x squared plus 5x minus 3, and raise it to the 2nd power, and then multiply everything by what? By the derivative of this polynomial, okay? Which is 18x minus 8x plus 5, okay? And that's it. That's the derivative using the chain rule. All right, number 6. Okay, let's say you have 4x over 3 minus 5, but we're going to raise this to a negative exponent. So what is the derivative? Let me enclose it, okay? So what is the derivative of this? using the chain rule, because again, our base, I will keep on emphasizing that base is not plain x or not simple x. That's why we're using the chain rule, okay? So the derivative is going to be negative 6 times that same base, 4x over 3 minus 5. Now raise it to the negative 6 minus 1, so that's negative 7. And then multiply this by the derivative of this 4x over 3 minus 5, which is what? 4 thirds, okay? And that's it. You just have to multiply this 6 and 4 thirds, so you can reduce the 6 and 3 into negative 2 times 4 is negative 8, and then 4x over 3 minus 5, raise it to the negative 7. Okay, so let's look at number 7. So you have x squared over 8 plus x minus 2 over x to the fifth, okay? So let's say this is your y. Find y prime, the derivative. All right, now you see reciprocal here. So there's one reciprocal, and I have a video about shortcut, okay, on how to find the derivative of those reciprocal. So let me give you a short review on that. Let's say you have 2 over x. So whenever we have a constant on top and then variable x at the bottom, then that's what we call reciprocal, okay? And the way you're going to find the derivative in a very easy way is to multiply this numerator to the exponent 1 over the x raised to 1, but add 1. So now x to 1 plus 1, so which is now x squared. And then make sure you switch the sign, okay? So one more, let's say you have 3 over, let's say negative 3 over x to the fourth. So what is the shortcut to find the derivative of this reciprocal? So you multiply the 3 and 4, that's a 12, over x raised to what? 5. So you add 1 to that exponent 4, and then switch the sign. So from negative, we have a positive. Okay, so we're going to be using this shortcut when we get to find the derivative of this part of this expression, okay? So let's use the chain rule now. 5 times 1 right here. So 5 times 1 is 5. Okay, and then copy that same base of the exponent 5, which is the x squared over 8 plus x minus 2 over x. And then now raise to the fourth power, okay? Here we go. So we need to multiply this by the derivative of this base, okay? And the derivative of that will be what? 2x, okay? So the derivative of the x squared is 2x over 8. The derivative of the x is 1 because there's a coefficient 1 plus 1. And then for the reciprocal 2 over x, we multiply this 2 and 1. So that's, we're going to switch the sign. So now it's a plus 2 over x. Okay, exponent 1 downstairs will become a 2. Okay, so that's the derivative. Okay, we just need to organize our final answer. So the derivative is going to be 5 times x squared over 8 plus x minus 2 over x raised to the fourth times, okay, 2 eighths is 1/4. So you say x over 4 plus 1 plus 2 over x squared. Okay, so this is our derivative. All right, let's see number 8. All right, number 8, let's say we have to find the derivative of another reciprocal, okay? But this reciprocal is raised to the fourth power. So what is the derivative of that? Okay, so one easy way is to use algebra initially. So what I mean by algebra is we're going to go ahead and raise this 3 over x squared to the fourth, which is 3 to the fourth, 81. And then x squared to the fourth is going to be x to the 8. Okay, so you multiply 2 and 4. So what we did here is basically you distribute the 4 to the exponent 1 and 2. So 3 to the fourth and then over x to the 8. Then this is the one we're going to find the derivative. Okay, so what is the derivative of this reciprocal? So this is another reciprocal example. Just want to make sure you develop that shortcut. All right, so from the positive, it's going to turn into negative. And then what we do is multiply this 81 times 8. Okay, so 81 times 8 is going to be, all right, 648 over x to the 8 plus 1. So now it's x to the 9. Okay, now because it's a reciprocal, all right, so we're using a shortcut. We're using a shortcut, and you don't see the actual chain rule in it. Okay, so if I'm going to show you a way to do it using a chain rule, so it's okay, let me show. It's a little longer than what I just did. Okay, so if we use a chain rule here, 3 over x squared raised to the fourth. Okay, so what is y prime? So if using a chain rule, it's going to look something like, okay, I'm going to multiply this by 4 and, okay, 4 and 1 is going to be 4. Copy that same base and then raise to the third power. Okay, and then multiply this by the derivative of this 3 over x squared, which is a reciprocal. So it's going to be what? 6 over x cubed, only negative. And then when you simplify, this is 3 cubed, okay? 3 cubed is 27 times 4 times 6 is going to be negative 648 over, okay, now this 2 times 3 is 6, and then plus 3 is 9, so x9. Okay, so this is more tedious compared to the shortcut that we just did. Okay, so hopefully you remember a more efficient way to do it. So this is my recommendation. Okay, so do the algebra in the beginning and recognize that this is a reciprocal, and then use the shortcut, okay, to find its derivative. Okay, number 9. Let's say we have another reciprocal just to make sure, okay, that this is solid. So let's say 5 over x cubed squared. What is the derivative? Okay, prime. Again, an easier way is to rename it by distributing the exponent 2. Okay, so we can rename this by raising the 5 to the second power. Now it's 25. And then x cubed squared is going to give us x6. And then find its derivative. So again, recognize that this is a reciprocal, and we have a shortcut for that. Okay, so multiply 25 times 6. 25 times 6, I believe, is going to be 150. Okay, and then we switch the sign, the derivative of reciprocal, over x to the what? To the 7, because it's 6, and then you add 1. Okay, and that's it. Okay, how about one more reciprocal example? Let's say you have a negative 3 x to the fourth to the third. Okay, what is the derivative? So when you distribute this 3 in negative 3 over x to the fourth, that's going to give you negative 27 over x to the what? 4 times 3 is 12. Okay. Now, use the shortcut to find the derivative of this reciprocal. So this is a reciprocal. Okay, one more time. It's a reciprocal because we have a numerator which is constant. And then we have this base x as our denominator, okay, raised to some exponent. Right, so we have big numbers here. So the derivative is going to be what? The sign will switch, so it's now positive. And then what we do is multiply what? 27 times 12, okay? So we multiply 27 times 12, which is 576 over x to that 12 plus 1, so 13. Okay, super easy. All right, now let's focus on square roots. Okay, as a review, to find the derivative of square root of x, we have another shortcut for that, right? And that is every time you differentiate square root of x, by memorization, it's just going to be 1 over 2 square root of x. The derivative of square root of x is always 1 over 2 square root of x. You can do it the long way, and you're still going to arrive at 1 over 2 square root of x. So this, all right, is going to be very useful when you are going to get the derivative of square root of something that's not plain x. Let's say it's a 4x. What is the derivative? Okay. So we can still use the shortcut. Okay, we can still use the shortcut. It's always going to be in this structure right here. It's 1 over 2 and the square root of that. Okay, so it's going to be 1 over 2, the square root of that, which is 4x in this case. But because it's no longer plain x, okay, so it's not plain x anymore. Not plain x anymore. That means we have to use a chain rule, meaning you have to multiply this by the derivative of the 4x, which is 4. Okay, so this 4 and 2 will reduce to what? 2 over square root of 4x. Okay, so just do one additional step if the radicand or the expression inside the square root is no longer plain x. Okay, let's do one more. Let's say number 12. What is the derivative of square root of 3x squared minus 4x? A plus 1. Okay, so again, this is no longer square root of x, but it's still going to be in the form of 1 over 2 square root of that 3x squared minus 4x plus 1. We just have to multiply this by the derivative of this radicand here, which is 6x minus 4. Okay, and you can reduce this by 2. So our numerator is just going to be 3x minus 2 over the square root of the 3x squared minus 4x plus 1. Okay, number 13. Okay, how about the square root of x squared plus 10? Okay, so again, 1 over 2 square root of x squared plus 10 multiplied by the derivative of this x squared plus 10, which is 2x. Okay, and there you go. This is x over that square root of x squared plus 10. Okay, just use the shortcut. Okay, 14. Let's say you have a cube root instead. Okay, let's say this is a cube root of 3 minus 5x. Okay, for this one, we have to express this, okay, in rational exponent. So we can rename this as 3 minus 5x to the 1/3, okay, because this means raised to 1. So 1 over 3. And then we can use the chain rule for this one, okay? So what we do is multiply 1/3 and 1. That's 1/3. Copy that same base, raise to 1/3 minus 1, or 1/3 minus 3 over 3, which is negative 2/3. But chain rule says do one extra step, which is multiplying this by the derivative of that 3 minus 5x, which is negative 5. Okay, and then just simplify. That's negative 5 over 3. Now, if you want to move this at the bottom, because your exponent is negative, you may do that. So if you move the 3 minus 5x, okay, make sure you switch the sign of the negative 2/3 to positive 2/3. All right. So this is the process we use whenever we have an index that's no longer 2. Okay, so let's say cube roots or fourth root. Okay, let's look at the last example here for this part 1 of the series for chain rule. Okay, so what is the derivative of the fifth root of x to the 7 plus 6x? Okay, so just like in number 14, what we need to do first is express this using rational exponents. So now this is raised to 1 over 5. Okay, so what is the derivative? So the derivative using a chain rule, so we first multiply 1/5 and 1, so it's going to be 1/5 x to the 7 plus 6x raised to 1/5 minus 1. 1/5 minus 5 over 5, which is negative 4/5, and then multiply by the derivative of this x7 plus 6x, which is 7x to the 6 plus 6. Okay, and that's it. Okay, so hopefully I see you on the second part of this series, okay, using the chain rule. Okay, thank you for watching. I'll see you again.